Hello students, welcome to my class. Today I will teach you about acids. I will teach you all the properties and the nature of acids. I will include the physical properties and the chemical properties and the formulas. This chapter is going to be interesting. A short video about the basics of chemistry, you can say, which you should know when you are studying chemistry. So let us talk about the definition first. Acids are compounds which contain one or more hydrogen atoms, and when it is dissolved in water, it will produce hydronium ion H3O+, the only positively charged ion. Actually, the hydronium ion is the ion which plays the major role in giving the property to acids, like to show the color or the change in color of the indicator, its reaction, its properties. Everything about acid depends on hydronium ion, because this hydrated hydrogen ion, if you remember about the bonding chapter where I had showed you the diagram along with the bonding of how the hydrogen ion when it comes closer to the water molecule, it will combine to give you the hydronium ion H3O+, forming a dative bond. The acidic property of acid, as I told you just now, is all because of the hydronium ion. So this directly means that in the absence of the hydronium ion, the compound will not show any acidic property. So if you remember, when we were doing the HCl chapter, in the laboratory preparation, when HCl comes out as gas, that dry HCl will not answer to any indicator in the absence of water, actually directly hydronium ion. So we say that acid is a compound which has got one or more hydrogen atom. So when dissolved in water, it will produce the hydronium ion, and it is nothing but the hydrated hydrogen ion, hydronium ion. So we can say that HCl, it has got one hydrogen atom, so it will give you one hydronium ion and chloride ion. H2SO4 has got two hydrogen ions, so it will give you two hydronium ions and one sulfate ion. Nitric acid has got one hydrogen ion, actually atom, so it will give you the hydronium ion and a nitrate ion. Acetic acid, CH3COOH, will give you one hydronium ion, though it has got more than one hydrogen atom in its molecule, but it is a weak acid. Weak in the sense it will not dissociate all the hydrogen ions into water, therefore only one hydronium ion. So it's a monobasic acid. We will talk more about it a little later in the second slide of this video. As I said, I will also give you the names, some of the names and formulas of the acids and the common ones which you know, but still I have written it down for you. Hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3, acetic acid CH3COOH, oxalic acid H2C2O4. So there is a different way of writing. COOH and COOH bonded the both carbon atom, but per molecular formula is this. Sulfurous acid H2SO3, carbonic acid H2CO3, phosphoric acid H3PO4. We also know about some of the naturally occurring acids which we know, but many a times we don't realize, like vinegar. This everybody knows, it's acetic acid. The citrus fruits or lemon, oranges, they have citric acid. Rancid butter, butter, rancid butter has got butyric acid. Gastric juice in our stomach has got HCl. This all of you know it. Bee stung, the sting of bee and ant has got formic acid, which gives a very burning sensation when they sting. Sour milk, lactic acid, I'm sure everybody knows this. Apple, malic acid. Tomato, oxalic acid. Grapes, tartaric acid. So these are some of the names, and there may be many more in your text. So I would suggest children, please refer to your text as well, because there are many small little things which the teachers ask as fill in the blanks, so that you will be 100% sure only when you read the chapter. So I have always stressed on please read the chapter, because when you read the chapter you have prepared it 40%, and I'm telling you children, if you go through my videos, they are going to help you so much that you are really going to score very good marks in chemistry. But please listen to what I say during my videos. Formulas important, as in acids. Definition, give reason. Yes, these are some of the questions which are very common when they are asked. Children, please like, share and subscribe my channel, and please put your doubts in the comment section. Okay, now next slide. Now we come to classification of acids. Acids can be classified on the basis of many things. Basis of their strength, basis on their sources, basis on the amount of water present, basicity. There are many things. So first thing that I have noted down here for you all is sources. That means whether it's an organic acid or an inorganic acid. Organic acid from many living parts or living beings we can get, and the examples are oxalic acid, acetic acid, formic acid. There are many more in your text. I would suggest please know all of them. Inorganic acid, everybody knows, HCl, hydrochloric acid, sulfuric acid, nitric acid. Okay. Then on the basis of oxygen present in the compound. So oxyacid means one oxygen atom will be there, at least one. Nitric acid, sulfuric acid. See, HCl does not have, but sulfuric acid, nitric acid, they have oxygen in their molecule. Similarly, since oxygen is not there, they are named as hydracid, like HCl, HBr, and these are normally non-metallic elements present along with hydrogen. Then depending upon the basicity. Basicity means the number of hydrogen ion, just now we were talking about, produced per molecule of an acid in water. So when an acid is put in water, one molecule of acid is resulting in how many hydronium ion, talks about the basicity. So it can be monobasic, dibasic, tribasic, as in 1 hydronium ion, 2 hydronium ion and 3 hydronium ions. So 1 and 2 we discussed just now in the previous slide, HCl and sulfuric acid. They can be 3 also, tribasic, that is phosphoric acid. So I was also talking about this acetic acid, why it's monobasic, though there are more than one hydrogen atom in the molecule. But the thing is that all the hydrogen atoms cannot produce hydronium ion. It will not dissociate, therefore it's a monobasic. Only one hydronium ion can be produced. At the same time, if you talk about phosphoric acid, H3PO4, it is a tribasic acid. But at the same time, phosphorus, H3PO3, is dibasic, because the hydrogen attached to oxygen are replaceable, but the hydrogen attached to phosphorus is not replaceable. So the 3 hydrogen, 2 of them are with oxygen and 1 of them is with phosphorus, which is not replaceable. So it's a dibasic acid, though there are 3 hydrogen atoms. Very important. You can expect one question from here, so please learn the answer properly. Then on the basis of the strength, whether it ionizes completely or it does not ionize completely. Normally the inorganic acids are strong acids because they completely ionize, and the weak acids, they do not. Organic acid, carbonic acid, these are some of the names. There are many more in your text. As I said, please do not leave any example. Then very important, concentrated acid contains small amount of water. Now the question is whether the acid is concentrated or dilute. Talks about whether the amount of water present in the acid is more or less. Very little or less, it is a concentrated acid. More, it's a dilute acid. So if it is a strong acid, with less water it becomes concentrated, and with more water it becomes dilute. So please concentrate here, don't mix the two, because strength of the acid has got nothing to do with the concentration of the acid. Strength completely depends on ionization. Concentrated ones depends on the amount of water. These two are two different things. Please don't mix them up. A common mistake which children do. Coming to preparation. Acids can be prepared by many methods. First one, method by synthesis. Normally with the non-metals, as we were talking about just now in the hydracids with non-metals, they will directly combine. Hydrogen and chlorine, two elements will combine to give you HCl. Similarly, hydrogen and bromine giving you HBr. By the action of water on non-metallic oxides, that is acidic oxide. This is a very common thing which you have done in standard 7, where we used to teach you that a non-metal with oxygen will give you a non-metallic oxide. And we used to show you the reactions like carbon and oxygen giving you carbon dioxide, sulfur and oxygen gives you sulfur dioxide, nitrogen and oxygen gives you nitrogen dioxide, and we had named them as acidic oxides. And the reason that was told to you was also there, showing that these non-metallic oxides, or these are known as acidic oxides just because when they react with water, they give or they result in producing one acid. Exactly same we are doing here, like sulfur trioxide with water, SO3 with water will give you sulfuric acid. At the same time, SO2 with water will give you sulfurous acid. And please remember, when these are non-metallic oxides, they will always result in oxyacid because oxygen is present. Coming back, carbon dioxide with water will give you carbonic acid. Phosphorus pentoxide with water will give you phosphoric acid. Nitrogen pentoxide with water will give you nitric acid, but nitrogen dioxide with water will give both the acids, nitrous acid and nitric acid. So when we are talking about acid anhydride, acid anhydride of sulfuric acid is sulfur trioxide. The acid anhydride of sulfurous acid is sulfur dioxide. So what is anhydride? Leaving water. Anhydra. Without water, what is the acid anhydride? Or with what? Water with what will form you that acid is the acid anhydride. Then acid anhydride of carbonic acid is CO2. But the acid anhydride of nitric acid is not NO2. It is N2O5, because NO2 is a double acid anhydride of both nitric acid and nitrous acid. Very important here. Please pay attention. Next method is by the oxidation of non-metals. So sulfur with conc nitric acid gives you sulfuric acid, water and nitrogen dioxide. At the same time, phosphorus also with nitric acid, that's to conc, gives you phosphoric acid, water and nitrogen dioxide. These two reactions we have done in the previous chapter, so not new repetition. Then by displacement, this also we have done in the laboratory preparation of HCl and nitric acid, where NaCl with conc H2SO4 at a temperature less than 200 will give you sodium bisulfate and HCl. You can also get HCl at a temperature greater than 200 but giving you sodium sulfate, not bisulfate anymore. The same rule goes for sodium nitrate and conc sulfuric acid at a temperature less than 200 will give you sodium bisulfate and nitric acid. More than 200, the reaction becomes different. And this is also one example to give you a more volatile acid from a less volatile acid. HCl and nitric acid are volatile acids. Sulfuric acid is a non-volatile acid. Here this one can give you the result where a non-metal is used to prepare one acid. Here also the non-metal is used to prepare an acid. Now it depends on the question how it is put in. So please pay attention about that. Now there is one question. In order to dilute an acid, the acid is poured into water in small quantity with constant stirring. Why? This we have done in the previous chapter. And the reason behind is that if you pour water into acid, it will result into a exothermic reaction. A lot of heat is dissipated, resulting in the splash of acid and causing accident. Therefore, in order to dilute an acid, it is always acid to be poured into water, not water into acid, in small quantity with constant stirring, because water will have the temperature less, will be able to absorb more because specific heat is high. So a little drop of acid into water with constant stirring will result in a dilute acid rather than pouring water into acid, which is going to be very dangerous. The answer is written very clearly in your text. Please see that you don't miss it out. Next question. Why is dilute HCl stronger than highly concentrated acetic acid? I think I explained it just now. Please look for the answer in your text or watch the video just now, the previous slide. It will help you give the answer. So look for the answer, please. Now the next slide. We come to now the properties of acids. So the physical properties, sour taste, but do we normally taste and check? No, because we know that the mineral acids are going to be very dangerous, or any acid is going to be very dangerous if you are trying it out. So please don't, because they are corrosive in nature, and mineral acids are highly corrosive in nature. They result in burning the skin like anything. Any other particle also it burns because it's highly corrosive. It can be found in the solid or in liquid state at room temperature. There are a number of examples given in your text. I think you should not miss it out. As I told you just now, corrosive nature, it causes as painful burns on skin, resulting in blisters, especially for HCl. Otherwise, conc H2SO4 will turn, that is stain, black. Nitric acid will give it yellow, and conc HCl gives amber color but results in painful blisters, and each one has its own reason behind. Sulfuric acid is a very strong dehydrating, so it will quickly take away the water from the carbohydrate present on the skin. Nitric acid also will react with the protein to give you xanthroprotic. This we have done in the previous chapters, and HCl is causing blisters with amber color. Moreover, the acids result as good electrolytes because they can ionize, so it will be resulting into good ionize. To identify the acids, we take the help of indicators, as always done in the previous chapters also, where blue litmus turns to red. These are organic compounds, plant products. Methyl orange turns orange to pink, and phenolphthalein remains colorless. There is no change, which shows that it's an acid. There are questions like what are indicators, name to acid of solid state, and so on. Small questions of 1 mark which you should not miss. Please don't forget to solve the exercise as well, because there are many questions which we normally take Coming to the chemical properties, the basics about all chemical properties, and gives you a strong chemical base also if you are studying chemistry. So we all know that active metal with dilute acid will result in giving you salt and hydrogen. Now in this particular property, please do not go for sodium, potassium, because they are going to be very vigorous in the laboratory. So we normally go for magnesium, zinc and iron. I have taken 2 examples here. Magnesium with dilute HCl will give you salt, magnesium chloride and hydrogen. At the same time, iron with dilute sulfuric acid gives you ferrous sulfate and hydrogen gas. Nitric acid is not used here to produce hydrogen, because nitric acid, as you have studied in the previous class also, I have written it down, it's there in your text also. It's a very strong oxidizing agent, and it will quickly oxidize any metal, non-metal gas. Here it oxidizes hydrogen and forms water. Therefore, it defeats the purpose. But manganese with 1% dilute nitric acid, that is very, very dilute at a very low temperature, will give you salt and hydrogen. So this is exceptional. Otherwise, nitric acid does not produce hydrogen at all. Then we talk about the neutralization reaction, because a base is a metallic oxide or a hydroxide, and about base I am going to talk about it in detail, property and preparation in my upcoming next video. So metallic oxide or a metallic hydroxide is a base. Now this metallic oxide or a metallic hydroxide with a dilute acid will give you salt and water, which is the definition of neutralization reaction. I have taken only 2 reactions here. Copper oxide with sulfuric acid gives you copper sulfate and water. Sodium hydroxide and nitric acid will give you sodium nitrate and water. The next type is a metallic carbonate or a metallic bicarbonate with acid will give you salt, water and carbon dioxide gas. We have spoken about all these properties in the HCl chapter. I am redoing it because these are really important for chemistry. So we've taken 2 examples with calcium carbonate and calcium bicarbonate, both with dilute HCl will give you calcium chloride, water, carbon dioxide, and one most important thing, please do not forget to balance the equation. Otherwise, even if your products are correct, you're not going to get that 1 mark. I have been repeating it in almost every video of mine, because that 10 marks for at least 10 equations are really important from examination point of view. But we should always remember that if the salt formed is one insoluble one, it will stop the reaction or it will not proceed. Like lead carbonate will not react with dilute HCl because lead chloride is going to be insoluble. At the same time, lead sulfate also. So lead carbonate will not react with HCl or sulfuric acid. Calcium carbonate with that's why not react with sulfuric acid, because calcium sulfate is going to be one insoluble salt. Therefore, you should remember this. It is there in your text also. Please don't miss that out. The next slide. Chemical property. Metallic sulfite or a metallic bisulfite with acid will give you salt, water and sulfur dioxide. So if you remember HCl chapter, we were speaking about the observation and the differences also. Like how will you differentiate between calcium carbonate and calcium sulfite? In the previous slide, I had just showed you with dilute HCl, it gives you calcium chloride, water and carbon dioxide. For a sulfite, it will give you calcium chloride, water and, for the previous one, calcium chloride, water and carbon dioxide. Here it is a sulfur dioxide. But for a difference question, we don't go for the name of the product or the equation. We directly come to the observation. So here the differences will be sulfur dioxide and carbon dioxide. So if the colorless gas is passed through acidified potassium dichromate, the solution will turn from orange to green, or it will decolorize potassium permanganate solution. We had been doing it in the practical chemistry in the HCl chapter. We are doing it again. It will answer the same for the observation as well as for a difference question. Coming to the metallic sulfide with acid will give you salt and H2S gas. The reactions are very common. We now come to certain types of reaction with conc H2SO4, which we have done with sodium chloride for the preparation of HCl gas, and with two different temperatures, less than 200 and greater than 200, because chlorides do not react with any dilute acid. But yes, with conc H2SO4, on heating and the temperature difference will give you two different results. This was done in the laboratory preparation of HCl and a repetition. So if you have already prepared it from the HCl chapter, it will be simple for you. If you are still to do the HCl chapter, please refer to that video of mine. Then we have also seen that the nitrates react with the conc H2SO4, that is potassium nitrate and sodium nitrate, for the preparation of nitric acid. This again goes to the laboratory preparation of nitric acid. And we have seen that the metallic nitrates do not react with any acid, but silver nitrate, potassium nitrate and mercury nitrate will react with dilute HCl to give you the precipitate of their chlorides and nitric acid. These precipitates don't dissolve even in the strong nitric acid, but they will dissolve in the ammonium hydroxide solution. This also we have done in the HCl chapter. So if you can refer to that video of mine, it is going to be clear once again. Chemistry, as I have always told you, it is interlinked, children. So whenever you have a doubt, please go to that particular video and forward it, watch that part and come back to this. Okay, so there are some questions also which I have written it down for you. Please check if you can look for the answers. Otherwise, I am there to help you. How do we dilute an acid? We have discussed. Name and draw the structure of the positive ion formed when an acid is dissolved in water. I discussed in the first slide. Acetic acid is monobasic acid. How? Done just now. How is acid prepared from a non-metal? Give the chemical equation. Give two examples of oxyacid, hydroacid and tribasic acid. So this was all about acids, the properties, the preparations, the basic idea about chemistry and so on. And I am 100% sure you will understand the video and you will like it. So children, please like, share and subscribe my channel. Take care, children. Bye.